Okay, guys, today we're going to look at applying rational expressions to real life applications, okay, when it can be used and so forth. So here's my first problem. One pump can fill one tank of oil in 4 hours. The second pump fills one tank of oil in 3 hours. If both pumps are used at the same time, how long will it take to fill the tank? Okay, meaning we're putting both pumps in to the tank at the same time. We want to know the time it's going to take. So I put that right there. Now, we've done a problem like this already, okay? So I've got hours and tanks. That's X and that's Y. Now, the tanks per hour, I don't really know that. Now, before I just, and I'm guessing it is linear because they would pump at a constant rate, but I'm not really going to worry about that because here's the deal. When they pump at the same time, the line is because they're at the same time, X comma Y, MXY. But without any hours, we're not going to have any gallons of oil pumped. It's a direct variation. Okay, the two variables vary directly. So then what I'm going to do is make an equation with ratios. This is the tanks pumping together. And right here is going to be the tanks pumping separately. So we want to put the time unit on the bottom. So hours, 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 and then tanks, tanks, and tanks. Okay, so I know that one pump working by itself can do one tank in 4 hours. Another one can do one in 3 hours. Now, when they work together, they're still going to fill up one tank, but I don't know the hours it's going to take to do it. Now, if you remember before, what we did was we just added 1/4 plus 1/3. Okay, and that can be done on a calculator. 1/4. Excuse me. Kind of got a cold, so I'm going to be coughing and wheezing a little bit. So 7 over 12, and then 1 over x. This stays 1 over x. Now I could just multiply and divide. 1 times 12 is 12, divided by 7, 1.7 hours. Okay? And we had done that in the fall, but now the game changes. Okay? You can stuff envelopes twice as fast as your friend. Together you can stuff 6,750 envelopes in 4.5 hours. How long would it take each of you working alone to complete the job? Okay, so I want to know the hours. So my boxes, I'm going to have hours and envelopes. That's X and that's Y. So per. The envelopes per hour. Now, unless I got tired, which stuffing envelopes doesn't really take that much energy, we're going to be working at a constant rate here. So even though I don't know the envelopes per hour, this is a linear progression. X comma Y, MX, Y. But without any hours of work, there's no way we get any envelopes, so that's direct variation. Okay? So that means I can use ratios, but I'm going to actually use 3. There's me, my friend, separate, and then when we join forces and work together. So I'm going to put hours in the denominator, and I'll put envelopes, EN, you don't have to spell the whole word, in the numerator. Time's got to go in the denominator. Okay, now it says what we can do together. We can stuff 6,750 envelopes in 4.5 hours. Now, if we were working separately, we would still have to get, if one person disappears, we'd still have to get 6,750 envelopes stuffed. But I don't know the time it takes to do it. But one thing I do know is that I can work twice as fast as my friend. So what I can have these unknowns be if it's twice as fast is 2x and x, not x plus 2. It has to be 2x. Okay, now I can't exactly add these because there are x's in both denominators, but what I do instead, make 3 new ones, and none of these need to be parenthesized because there's really no adding or subtracting on 6,750, and then 2x is just a monomial. 6,750 and x, 6,750 and 4.5. But what I do need to get is the lowest common denominator, the LCD. So I have an outer 2. I have an outer x. And I have an outer 4.5. Okay, so what do we have for outer 2's? I have 1, 0, 0. Okay, so in the 0 ones, we got to bring our own 2 in here. Okay, outer x's, I have 1, 1, and 0. So I need to bring an x into that one. Okay, and then 4.5's, I have 0, 0, 1. Okay, so times 4.5 times 4.5 times 4.5 times 4.5. Now, the three bottoms are canceled, and you don't need to go to your math papa here because there are no parentheses you need to multiply through. It's just straight multiplication. So in the first fraction, I take 6,750 times 4.5, 30,375. Plus, and then here I'll take 6,750 times 2 times 4.5, and that's going to be 60,750. And then here I'm going to take 6,750 times 2, and then I'm going to attach an x onto the product. So 13,500, but that would have an x connected to it. Okay, well, what I can do is I can just add these. They're like terms. They can be added. So 30,375 plus 60,750, 91,125. And over here we got 13,500 times x. So now if I divide, I pretty much have the problem solved. Okay, I got 6.75 hours. Now, that's for the guy who works faster, because I wanted to know how long it would take each of you working alone. So if the other guy is going to take twice as long, because that's the faster guy, we need to multiply that by 2. 6.75 times 2, and I get 13.5. Okay. Okay. Next one. Working together, you and a friend can paint 6 houses in 4 hours. 4 houses in 6 hours, sorry. If your friend paints twice as fast as you, how long will it take you to that's what that should say, to paint the 4 houses if you work separately? Okay, so I want to figure out the number of hours. So I have hours and houses. So I assign the x to the hours, the y to the houses. And then houses per hour, I don't know, but I'm guessing it would be relatively constant, meaning I could do the same houses every hour unless I got tired, which is possible, but we're going to pretend we don't. So it's a linear progression. And we also don't have to worry about a beginning amount, so that's direct variation, so we can use ratios, but I would want 3 of them. This is when we work together, but then there's us working separately. Okay, now I need to put the time unit in the denominator. And then the dependent variable, the unit goes in the numerator. So this is what we can do together. So 4 over 6. Now, we're still going to have to, even if they separate us, we still have 4 houses to paint. That fact doesn't change. But the time it takes us to do it is unknown. But I know that one paints twice as fast as the other. So since these are both 4s, it doesn't really matter which one's 2x and which one's x. Okay? All right, what we do need to do is come up with the lowest common denominator. So I just drop everything down because there's no factoring to this. Okay, it'll just stay the same. So I have an outer 2. Then I have an outer x. Then I have another outer x, which I've already said I had, and then outer 6. So outer 2's, I have 1, 0, 0. Okay, so I'm going to times 2 and times 2. Outer x's, I have 1, 1, and 0. Okay, so times x. Outer 6's, I have 0, 0, and 1. Okay. So I need to times 6 times 6 times 6 times 6. And these are now all the common denominator, so I can just forget about it being a fraction, okay? So 4 times 6 is 24. 4 times 2 is 8 times 6 is going to be 48. And over here, 4 times 2 is 8 with an x connected. Now we can just add those two, okay? And that's 72. That's 8x. Okay, so then I divide by 8, and x equals 9. Okay, so this guy here, takes him 9 hours. The other guy's twice as long, so 2 times 9 is 18. Okay, so again, with the twice, you just times 2. Don't add 2, which is what a lot of people like to do. Okay, together you and a friend can type 50 pages of report in 3 hours. You can type twice as fast as your friend. How long would it take each of you to complete the job alone? Okay, so hours. Okay, so I have hours and pages. Now you got to understand, I can type at a relatively constant rate because all I'm doing is looking at a paper, typing it. So even though I don't know the pages per hour, I'm guessing it's probably a constant. So it makes linear progression, not exponential, okay, with the curve, because it'd be repeatedly adding. But there really is no initial amount because without any hours, we can't get any pages typed. So that's a direct variation. Okay, so I put my time unit in the denominator and the y unit in the numerator. And we actually know what the given information is when we work together, so that's going to be here. And then if we work separate, if the other guy bailed on me, I'd still have to type 50 pages, and so would this guy, but the twice as fast is x and 2x. And again, they're both 50s, so it doesn't really matter which one's which. All right, so we need to come up with an LCD. We aren't going to be able to just add the fractions, so I drop everything down because there's no point in, with no parentheses, there's no point in seeing, oh, do I have to factor? No. So LCD, we have outer x. We have outer 2, and we have outer 3. Okay, so outer x, 1, 1, 0. So I'm going to multiply by x here. Outer 2, 0, 1, 0. Okay, and then it's just about the 3, 0, 0, 1. So I times 3. Times 3 times 3. And those can now be crossed out. Okay. So over here, 50 times 2 is 100, times 3 is 300. 50 times 3 is 150. Then we're going to have 100x. Okay. So it's going to be 450 equals 100 times x. So I divide by 100. I get a decimal, but that's okay. So x is 4.5. So I have 4.5 hours, but it wants to know how long each of us would take alone. So this is actually the faster guy. The other guy is going to be doubled, so times 2, and that's 9.